How do you communicate with other people if they do not understand the language you speak? Or say with animals whose language or gestures you do not know about? This is a diverse world. It is. But we know this communication is possible. The question is how efficient it is. Now let's talk about our code. How about the diverse distributed systems that you build? And as developers, how do you make them talk with each other on the internet efficiently? RESTful web services is one of the answers to this problem. Hi everyone, thanks for joining in. I'm your host Mala Gupta. And in today's session, you'll see how to build REST APIs in Java with Spring. This is a live coded session, so you get to see all the talking in action. And by the end of the session, you'll know how to create a basic CRUD REST API in Spring Boot. You'll also learn about some of the best practices to create your APIs. Now, let me add our speaker to the stream. Hi and welcome, Dan. It's a pleasure to have you present with us today.
Thank you so much for having me, Mala. So happy to be here.
Great. And Dan has been building applications for the web for almost 2 decades now. And I wanted to say this, his superpower is problem solving. So here he is helping us to build the CRUD applications that we talked about. And before I let Dan take the stage, here are a few housekeeping details. Everyone who's watching the session, please use the YouTube chat to post your questions. Yuri from JetBrains, I and Dan would answer your questions also during the session and also towards the end of the session. The session is being recorded and it will be hosted on our YouTube channel. So if you haven't already subscribed to our channel, now is the time to do that. And if you like today's session, which I'm sure you would do because Dan is live coding, please like the video. So Dan, let me add your screen to the stream and good luck.
All right, thank you. Thanks again, Mala, for having me. I appreciate it. I'm excited today. Today we're going to be talking about building REST APIs in Spring Boot. My name is Dan Vega. I'm a Spring developer advocate with VMware. Today, I just want to get some things out of the way. There's going to be just a few slides to kind of set the stage on what we're going to talk about. I want to be very upfront and say today is really a beginner-focused presentation on building REST APIs with Spring Boot. Now, even though that it's kind of beginner-focused, I always like to say if you can come away with one or two kind of nuggets out of a presentation, then it's well worth sitting through. So go ahead and throw this on in the background if you're working and see if you can pick up a couple things. Like I said, we're going to do a lot of coding. I just have a few slides to go through to kind of set the stage for what we're going to cover today. So really, we'll just get into a quick introduction of who I am in case you don't know. At a high level, I want to talk about APIs and REST in general. I don't want to get too bogged down in the weeds of what we're doing as far as REST goes. I'm very much, at least my style of teaching is kind of moved to this, is let's talk about the mechanics of how we're going to build these things today. We'll get into the weeds of like more REST principles later on, but let's learn the mechanics first instead of spending 30 minutes on slides and learning principles of REST. So this will be a good time to just kind of give that a high-level overview, and then we'll get into a lot of coding today. When we leave here today, I'll give you some resources, some kind of next steps, a little bit of a deeper dive into some of the topics that we talked about today, and then some of the things that you can learn after you kind of learn this. There is a GitHub repo for this. You'll see the link there, github.com/danvega, building REST APIs in Spring Boot. That contains all the code that we're going to cover today. So a little bit about me. I'm a husband and a father. There's my beautiful wife, Jen, my two daughters, Isabella and Juliana. We live right outside of Cleveland, Ohio. I've been a software developer for over 20 years, and in that span, held a variety of titles from web developer to senior engineer to curriculum developer to principal architect, and now Spring developer advocate. And this is really kind of a culmination of all of those things and really a dream job for me. I've been a huge fan of Spring and the ecosystem for a long time now. And this is what I get to do every day now, is talk to you guys, talk to customers, and help them find solutions to problems using the different projects in the Spring ecosystem. So really excited about this. There's going to be a lot more presentations coming up. So if you want to, please go ahead and follow me. You can follow me over on danvega.dev. I'm a blogger, a YouTuber, course creator, and as I mentioned before, I live outside of Cleveland, and I am a Cleveland sports fan, which is why I tell people I'm usually miserable. So let's talk about APIs. So at a high level, if you don't know, API stands for Application Programming Interface. And in the world that we live in today, at the heart of all the applications we're building is data. And what's really important about that data is being able to share that data out, right? So microservices are a big term, a big buzz these days. The last position I was at, worked for a top, Fortune 50 company, and they were moving a lot of things to microservices. And there are so many microservices across the enterprise, and they need to talk to each other some way. There are a couple ways to do this. You can use a synchronous API in the form of, say, REST. If you need to make a call to another service and get some data back, you can use asynchronous. If you start getting into event-driven architecture and you want to just throw something out there and wait for communication back, using something like Kafka or RabbitMQ. So there are different ways to talk to these different microservices. One of those ways is obviously through, say, a REST API. And it's becoming even more and more important with all the different devices that we're using. So it's no longer just the phone in our hand, right? Our TVs can have computers in them now. Microwaves, bathtubs. I mean, it's crazy the things that are getting chips in them these days. So all these different devices need to talk to something to get data down or push data up, right? And this is done through APIs. So that's an API. What is a REST API? So it's important to understand that a REST is more of a guideline than a protocol. REST uses the HTTP protocol and then defines some constraints on top of it. It's also important to know that REST is not this definitive thing. You don't need to there are some principles. We'll kind of talk through some of them as we're building this out. There are some principles, but these aren't like hard rules. Like you must do this or you are not REST. I mean, some people will tell you that, but at the end of the day, you try to strive towards REST. Once you get past some of the beginning kind of CRUD features, after you're done filtering and paging, then you start to blur some lines. And to be honest, it's okay. You're just trying to strive towards, striving towards some of these principles, right? So there are 6 principles of REST. You'll see them in work today, but I'm going to leave you a resource to go ahead and learn more about them after today's presentation. There are also building blocks of REST, things that you need to understand, like HTTP methods, status codes, URLs, etc. So we'll cover some of those. And again, like I said, that's all I really had as far as slides go. I want to get into some demo here and build something out. So let me just make sure we are here. Again, this is the repo if you want to go ahead and follow along. Don't need to code along today. I suggest just kind of watching this. You can come back to this code later. And again, if you have questions, go ahead and throw them up and we'll try to get to them throughout this demo. So to create a new Spring Boot project, we all know, you should know that you go to start.spring.io. And I want to show you this great little feature here. You see this little blue star? This little blue star means I favorited it. Use it. Use that in your browser because you're going to visit start.spring.io a lot. So why not go ahead and bookmark it? So here we are on the Spring Initializer. And what we're going to do is we're going to provide some metadata about the project that we're going to create. So I'm going to go ahead and choose Maven and Java and then the current version. I'm going to just put some data in here. So dev.danvega, we'll call this streams schedule. And then we need to pick, if you look down here, jar, and then we need to pick a version of Java. So this is a good time to mention that at the end of this year, Spring Framework 6 and Spring Boot 3 are coming out. And one of the big changes in that is going to be at a baseline of Java 17. Now, this may seem a little crazy, but the world that we live in now with Java is changing so frequently, this makes sense. And Java 18 is going to come out next month. It's just crazy. It's a great time to be a Java developer with all this change happening and additions and performance gains to the language. So we're going to select Java 17 here. And then we need our dependencies. So I kind of liken this to throwing a dinner party. So if I was going to throw a dinner party, I might prepare some type of menu. I'm going to say, we're going to make some pizza. We're going to have some wine, some cheeses. So if I'm going to throw this dinner party with those things, when I go to the grocery store, I'm going to write down all the ingredients that I need. So whatever I need to kind of make that dinner happen, I'm going to put on a piece of paper. I'll probably group them together by the layout of the store I go to a lot. So I know that I'm not like inefficiently walking around, right? But I have an idea of what I need to get when I go to the grocery store. Same thing with my application. I kind of know what I'm going to build today. So I know what things I need to add to this application. Now, if you forget something in a grocery store, you can always go back to the grocery store. Same thing with here. If you forget something, you can always add it later, right? So what we're going to build today is just a simple API that allows me, so over on my live stream a lot lately, I've been building out a way for me to build a schedule of all of the live streams so that I could throw this on my website. Anybody who wants to come check that out and see when I'm live coding next, you can go ahead and view that there. So we'll kind of build an application around that idea. So when we add dependencies, we need to figure out what we're going to be building. So in this case, our first one is we can choose between Spring Web and Spring Reactive Web. So Spring Web is traditional Spring MVC, uses Tomcat with the default embedded container. If you wanted to, if you were getting into any type of like blocking IO, talking to databases, talking to other APIs, Reactive Web is a great solution for that because it moves away from the traditional thread per request model. So you can look at that, but today we're just going to stick with web because what we're doing is pretty simple. Now, one other thing we're going to need is as we are accepting data from people, so if we want to create a new resource or update a new resource, we're going to ask for input from someone. And what we need to do often is we need to be able to validate that data. And it used to be that the validation dependencies were right there embedded in the web or the web MVC dependencies. That is no longer the case. So if you're going to do validation, you need to make sure you search for validation. And here we're going to go bean validation with Hibernate Validator. Some people get tricked up by this. Just because Hibernate Validator is in there doesn't mean we're using Hibernate. So we're not using Spring Data, JPA, or anything right now today. We could move to that, obviously, and we should once we start to introduce that stuff. We're just going to be using some in-memory representation of our data, but that bean validation with Hibernate Validator is what we need to create this project. So at this point, you can click Explore. This is an awesome feature that I love, being able to see kind of what this POM looks like, what are we pulling in, what is the structure of the project. And it's important to note that we're not generating code. Like there is some code in here that we're going to start with, but it's not generating like some entities or anything based on what you've selected. This is really just bootstrapping your application and getting you up off the ground, up and running as fast as possible. So at this point, you could generate this project and open it up in your favorite text editor or IDE. But at this point, I want to show you another way to do that, and that's with the fine folks at IntelliJ. I promise you, they are not paying me to do this. I am a paying customer of IntelliJ. I have been for a long time, just for my personal projects, because I just think it's a fantastic IDE. So I am using the IntelliJ IDE, the Ultimate Edition today. If you're going to use this startup, the new Spring project wizard that we're going to go through today, you do need the Ultimate Edition. But if you have the free Community Edition, that's fine too. You can just use start.spring.io like we just did and open it up right there in the Community Edition. So another thing I really love about IntelliJ is that, you know, I was talking to a friend over the weekend who is new to coding. He's learning how to code. And he's a Java developer who is working on Android projects. And one of the things he told me was he really loves the fact that like when he writes some code in IntelliJ, there's little hints on like how he could refactor his code. So like, hey, when you write a for loop, hey, you could probably turn this into a stream and filter and map and reduce on that. Or, hey, this would be a good opportunity to use a Lambda function. So I've always told people that, but it was really great hearing from someone else that like he really enjoys that fact of IntelliJ. So big fan of IntelliJ. We're going to use that today. I'm going to go ahead and click on this new project, and we're actually going to build out the same thing we just did on the web. So I have a streams schedule. We're going to use Java. We're going to say dev.danvega, And again, we're going to pick Java 17. We're going to use jar. As Josh would say, make jar, not war. Directory is empty. That's OK. So again, we're going to come in here and pick our dependencies. We're going to use Spring Web. We're going to use validation. And we're going to click Finish. So the first thing that I like to do when I create a new application is I want to just come in here and make sure that it runs. I want to make sure that nothing weird is going on and that my application is able to run. So I'm going to go ahead and click Start. And there we go. Our application is running on 8080. Great. So let's go ahead and hide this. And I'm just checking to make sure there are no questions. Okay. So the first thing we're going to look at is just the POM XML real quick. This is using Maven. So Maven generates this. Maven has this. Maven build tool has this POM.xml. And if you're new to Spring Boot, one of the things you might look at this go, wow, there's really not a lot of dependencies declared. And that's one of the great things about Spring Boot is that that's how it helps us get up and running so quick is these starters. So the starter, Spring Boot Starter Web, if you have ever tried to build a web application in Spring without Boot, trying to figure out all the dependencies that it takes and custom, configure an embedded Tomcat container, it's kind of a pain in the butt. So if you click in here, you can see that this starter actually includes other starters and includes other dependencies. And so this is how Spring Boot, one of the things, the kind of magic of Spring Boot is, and how it's able to get you up and running really quick. So that's our application. It's working. I thought that we didn't have anything here. Sorry about that. I must not have deleted our starting code, but no big deal. This is actually good because now we can keep all of our packages there and we'll build this out together. So here in the model directory, so the first thing that we're going to do is really start with the model of our application. Going back to kind of domain-driven design, we're all trying to speak the same language when it comes to our application. So we need to model our application based off of something that we all can kind of talk about together, right? And in this case, again, we're building a live stream schedule API. So I want a place where I can create new live streams, have properties on it like the title, the description, the start date, the end date, what we're going to do in that live stream, and then be able to display that on a web page somewhere. So I'm going to create this here in our application and then make it available through an API so that anybody can kind of pull that schedule down. So the first thing I'm going to start with is a model. And what I want to do is actually go through kind of a traditional way that we might have done this in the past and show you how we can kind of improve upon this. So I'm going to name some things a little funny here. This is going to be called a mutable live stream. And if you know the difference between a mutable and immutable, then you'll kind of understand where I'm going with this. But what I want to talk about is, okay, this is our live stream. What are the different properties that are going to be within our live stream? So I'm going to go ahead and create our mutable live stream. Whoops, this is our props. Live stream props. So these are the different properties that we would have in a model that represented a live stream. We'd have an ID, a title, a description, a URL, a start date, and an end date. And if you start to see some of these hints that come up, that is actually GitHub Copilot trying to code for me. I leave it on because I like to tell people about it, and actually does help me kind of shorthand some things as we're going. But if you see that pop up, that's what's going on. Okay, so now that we have all of the properties, we would normally just create maybe a no-arg constructor. We know there's an implicit one, but I'm going to just create one anyway. We might create getters and setters. So I'm going to come in here and create getters and setters for each of the properties in our mutable live stream. I may come down here and create a equals and hash code. So we're just going to generate all of this code. Yep, looks good. Let's go ahead and do that and finish. And of course, I probably need a ToString, so I'm going to generate that as well. So far, so good. So we have ID, title. Yep, so far so good. So now that we have this live stream, I want to go ahead and write a test for this. And actually, I might have these tests in place already so that we don't have to worry about writing these out. I do see, oh, okay, that's why. But here, let's go ahead and just get rid of these for now. I do have a test here to test out our mutable live stream. So we created, this is how I would normally, how I used to do it in an application. I have a mutable live stream object. I call it a stream, and I create a new instance of it using the noir constructor. And then I go through and I kind of set all of the different properties on there, right? So I'm setting an ID to just a random UUID and getting the string version of that. I'm setting a title, a description. So one of the, again, we've moved on to Java 17. We're starting to use some of the cool new features in modern Java. One of those is multi-line strings, having a bunch of text that had to be escaped into the next line, kind of ugly in our code, right? Now we can just kind of use this multi-line string, and we have this big description here. I'm setting a URL, I'm setting a start date, an end date, and then I'm just saying, hey, make sure that it's not null and make sure that the title that we have here is what we think it is. So if we were to go ahead and run this, that passes. But the problem with this object is that somebody can come along later and say, I want to set the title to something else. So now if we run this again, obviously this is not going to pass because we've changed that title. So this is how we've kind of traditionally built out a model, right? Using something that is mutable. Now, what we could do, what we have done is we can move to, let's say, an immutable live stream. And so again, we're going to have those same properties that we did before. So live stream props. The only difference here now is when we want to build an immutable object, what we can do is we can go ahead and say, I'm going to select all those and I'm going to say, these are final. These are final, okay? I don't want these to be changed after these are created. But again, IntelliJ is helping us out and saying, hey, you probably want to add a constructor parameter. And you're going to add a constructor to go ahead and set all of these fields. So now once you set all of these fields, they cannot be changed. So now instead of generating getters and setters, we're just going to generate getters here, right? We don't need our setters because if we try to create a setter here, IntelliJ is going to tell us again, hey, you can't do that. You've marked these as final. Once they've been set, you shouldn't be changing them. Again, we can come through and say, let's generate an equals and hash code. And we'll do that, and we'll do that, and boom, 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 boom. And we'll finish. And finally, we'll go ahead and create a ToString, and we'll save that. So now we have an immutable live stream. So let's go back to our test and take a look at this. So now we might have a REST test to create an immutable live stream. Now, in this case, we're creating an immutable live stream, stream equals new immutable live stream, and we're passing all the properties that we want to build to our constructor. So I'm passing in a UUID, a random ID. Here's the title. Here's that description again. I'm using that multi-line string, the URL, the start date, the end date. We're checking that it's not null and that the title is what it is. And this should pass. And again, this now prevents us from creating this object and somehow changing it later. Now, the reason I bring all of that up is because, that immutable live stream that we just created was great. That was a good step forward. There's still a lot of code. And I know there's things like Lombok out there to cut some of that down, but there are things you got to configure within your IDE to get Lombok to work. And quite frankly, I just want to write like code that is concise and that is kind of following some of these best practices. And so what we can do here in Java 17 is use something called a record. So let's just go ahead and call this live stream, but we're going to choose record instead of class. And in here, we're just going to go ahead and pass in some props. So all of these arguments are the same ones that we used back in those other two model classes. But now, this is all I have to do. I don't have to figure out how to write make sure that all of the fields are private, make sure that we have a constructor that accepts all of them, make sure that we have getters, equals and hash code, ToString, all of that stuff that was kind of boilerplate before. We don't have to do that now. So now if we go back into our test, let's go ahead and check this out, create a record. Now this code looks very similar to the one that we did before. When we start to work with record classes, though, there are some things that we can also do on it. If you want to, you can call the get class, and there's a isRecord method on there. So you can say, hey, if you want to find out if a particular class is a record or not, you can do so. All of those arguments or those fields that we passed into that record constructor there, those are components. So you can actually say, hey, get me all of those components and make sure those are equal. So if I run this, this should pass. And this also gives us a chance to go down into this target directory here, look at classes, and look at model, and look at live stream, and look at the generated code from our record. So you see this is pretty similar, right? We have some fields. We have a constructor that we can go ahead and create all of these items from. And then we just have getters. The only difference you may notice is you may write code that looks like get ID or get title or get description. These getters are just the name of the field. So when you have an instance of live stream and you want the ID, you'll just say stream.id, stream.title, and so on. So that is a record. One more thing I want to show you about a record. If you don't know, if you come in here, there are different, so you can work with constructors still. When you create a constructor here in IntelliJ, it's going to ask you, do you want a compact constructor or a canonical constructor? And so if you do a canonical instructor, that's everything. The kitchen sink, everything is there. So that's basically what was generated. But if you needed to do some type of validation in there, you could. If you don't want to deal with all those fields, you can go ahead and create what's called a compact constructor. And a compact constructor says, okay, we know you're going to get all of that information, but if I just want to work with, say, the ID, if the ID is equal to null, maybe we throw some type of illegal argument exception, right? So you can do some kind of validation there in your compact constructor. So that is all I'm going to do for the models. Just checking here. Any questions so far? Am I still here? All right. So that is.
Yes, sorry, Hayden. I was reading through the comments. So there are a couple of questions, but nothing that I should be asking you now. So I would let you move on with your flow. Okay.
Okay, sounds good. We're doing on time? Good. All right. So now that we've kind of modeled our application, we have the representation of a live stream. We know the immutable one and the mutable one were just things that we were playing around with. But this live stream record has all the properties of a live stream, like an ID, a title, description, URL, start date, end. These are the things that we're going to be, the properties that we're going to be working with. So the next thing we need to do is we need to create a new live stream controller. So let's go into this controller package, create a Java class, and we're going to call it live stream controller. So a controller class, right now, this is not a controller class, no matter. So the convention is to add the word controller onto the end of the class. It's not a requirement, but you'll probably see this convention a lot as you start to look at other people's code or look at open source projects. Right now, just because this name has a controller on it, this isn't a controller class. We need to tell Spring that this is going to be a controller class, and more specifically, that it's going to be a REST controller class. So we're going to add on this annotation, and this annotation is really just comprised of two other annotations. You'll see this in Spring a lot, that there are a lot of annotations that are just making it easy, and they're shorthand for composed annotations. So in this case, it's a controller annotation, and it is also annotated with @response_body. So if you go into response body, it just says, hey, this method should return the value that's bound to the web response body. In our case, by default, what we are using is JSON, so we're going to return JSON. So now that we've kind of told Spring that, hey, this is going to be a REST controller, there's something else we need to do. We need to go ahead and add this request mapping annotation and we need to give it a path. So this is one of the things we're going to talk about really when it comes to those 6 principles of REST. And one of those things is kind of a uniform resource, right? And when we talk about resources, we want to talk about being able to build our APIs that focus on a resource. And in our case, the resource that we're working with is a live stream. Too many times, more often than not, I've gone into code bases and seen APIs that kind of just have, methods all over the place. And they're said to be REST APIs, and they're not. When we're talking about REST APIs, we're working with a single resource. Now, a single resource could be in charge of other resources, but in this case, we're working with a single resource called streams. So now, when you hit /streams, that's kind of indicating that any method that we hit in here is going to be dealing with our live stream. And you'll see as we start to build this CRUD application out, all of them kind of fit under /streams. And then the way that each of these methods are differentiated is by the request method. So now the request mapping can go on the individual methods, but I like to set a base one here on the class to say everything underneath here is going to fall under /streams. And that'll make a little bit more sense in a second. So the first method that we might build out is we might build out something that returns a list of live streams, and we can call this find all. And let's just return null for now. We'll talk about this. And so what we want this to do is we want to be able to access this on localhost 8080. So by default, we run on port 8080. We can change that through configuration if we want, but by default, that's what we run on. And we want to run it /stream. So how can we tell this method that we're working on right now that this is the URL, the path that I want to be able to access this method on? So here, again, there is a request mapping annotation that we looked at before. There are also specialized versions of this, because if you use the request mapping, you have to say what HTTP method you're going to respond to. There are specialized versions of this where we're saying, hey, this particular one is a GET mapping. So this is going to respond to a GET request at this address. Now you'll notice that I haven't put any other path in here. I haven't said find all or whatever. We just want to respond to localhost 8080 /streams. So if we do that, because we've already set that request mapping up here, we can just have this as a GET mapping, and that will respond for the find all method. Now, we need a way to get some data in our application, right? So should we go ahead and add it here? Should we go ahead and say, well, I'm going to need a list of live streams, and we'll call this streams, and we'll initialize this to maybe an array list. And maybe in our constructor, I would go ahead and say this.streams. Oh, no, sorry. Streams dot add, and we'll say new live stream, and then we can fill this out and add a new live stream. So this is one approach that we could take, but it's probably not the right approach. So when we talk about a controller class, again, this comes back to Spring MVC. So this is model view controller, and the MVC pattern you'll find across whatever language or framework you're working with. There's probably some framework out there that kind of works with the MVC pattern. The C in that stands for controller. Now, controllers are meant to be thin and dumb. They aren't supposed to do a lot. They are supposed to accept requests and return responses. So right here, we're kind of already violating that when we're saying, let's manage some data in here, or let's do some other business logic in here. You don't want to do that in a controller. So I'm going to get rid of that. And what we need to do is we need to move this logic somewhere else. And where I'm going to move that is into a repository. So I'm going to call this the live stream. Well, let's type it right. Live stream repository. I often misspell things when I am live coding, so I apologize. So we're going to just go ahead and throw some code in here, because if we were to type all this out, this would take another hour. But what I want to do is just kind of walk through what this is doing. So a repository, similar to a DAO pattern, is just a way for us to kind of encapsulate some data access. In this case, we're not going to talk to a database. That's just going to kind of, complicate things a little bit. We're just going to have an in-memory representation of our streams. So I create a list of live streams called streams, initialize it to an array list. And here in the constructor for the repository, I go ahead and add a new stream. Again, similar one to before. It will have a random UUID, a title, a description, a URL, a start date, and an end date. Then I have some methods to access that, because again, you don't want to have data access methods in your controller. That should be delegated somewhere else. We're going to do that here in a repository. So find all is just going to return all of those streams in the collection. There's a way to find one by its ID. So it's going to search for an ID and return that. There's a way to create a new live stream, which basically just takes in a live stream object and adds it to our collection. There's a way to update one, and there's a way to delete one. So this is really just our data access, and this is all going to be contained within this class. So now what I want to do is talk about how we might use that data class, right? That repository class. So I might come in here to my controller and say, hey, I need a live stream repository. We'll call this repository. And maybe in my constructor, I might go ahead and create an instance of this. So repository is equal to new live stream repository. So this is one way that we could do it, but this isn't a very good way to do it. So there are a couple problems here. Now, if that live stream repository constructor ever changes, anywhere in our application where we've created a new instance of it, we may have to go update those. Also, if we are trying to write tests for this, this is going to be a problem, because maybe this live stream repository class is actually talking to a database. If we're writing something like a unit test that tests just our controller out, we want to get rid of all of those external dependencies, right? We don't want to be testing databases in a controller unit test. So, when the constructor is creating a new instance of it, there's no way to kind of, you could do some crazy stuff, but there's no way to say, hey, that live stream repository that you're using, let's go ahead and mock that out. So for those reasons and a couple others, anytime you start to use the new keyword in your constructor here, when you're newing up instances of classes within Spring, that's generally a smell for me that, hey, there's probably a better way to do that, and there is. So this is really a kind of a good time to talk about dependency injection. So dependency injection is really one of those core concepts that the Spring framework was built on. So dependency injection and inversion of control. And what inversion of control means is that instead of us being the ones responsible for creating an instance of that live stream repository, we're going to place that control on the framework. We aren't going to handle it. The framework will handle it for us. And really, dependency injection is going to solve a lot of problems for us. So let's take a look at how we might refactor that here. So what I'm going to do is I'm going to create a final live stream repository. I'm actually going to call this repository. And now IntelliJ is going, maybe I can help you out here. Why don't you add this as a constructor parameter? So here is a constructor parameter. Now, we're missing one thing here. So for Spring to really understand where this live stream repository is, we have to tell it where it can find it. And right now, this class is not something that Spring is managing. So the way that we do that in Spring is we can mark it with an @ component. If we dive into the @ component annotation, you'll say, hey, this indicates that this class, these classes are considered candidates for auto detection when using annotation-based configuration and class path scanning, so which we are by default out of the box. So all this is done is now said to Spring, hey, please manage this for me, create an instance for me, and when I ask for one, go ahead and give me one. And there's also, again, specialized annotation for things like repository. So I'm going to go ahead and mark this as a repository. When I come back over here to my controller, now I have a final live stream repository. We're calling it repository, and we're accepting this as an argument into our controller. So this is going to use constructor injection. We want to, so one of the things you may see in some code is coming up here and having this auto-wired annotation here on the actual dependency that you're trying to inject. And this is something you want to avoid. It becomes very hard to say test things. And as Josh Long says, every time you use field injection, a unit test dies. So don't do that. As in Spring 4.3 and above, you no longer need to mark a single constructor with the @auto-wired annotation. It just kind of understands that, hey, if you have that single constructor that accepts a particular argument, then we're going to assume that you want us to go ahead and insert that for us. So just checking my notes here and checking comments. Everything looks okay. So now at this point, now in our method where we want to go ahead and get a list of all the streams, we can go ahead and say, hey, ask that repository and go ahead and find all, because there's a method in there called find all. That will return all of the streams that we've set up in that live stream repository. Okay, so let's try and rerun this. Oops, sorry, don't want to run that. Want to run this. Okay, and this has started on 8080. So now if you've created this API, one way to test this is you could go back to the browser, and let's try and do that. So one way is we can come back to the browser, go to localhost 8080, and then go to /streams. So remember, that's how we set up that request mapping. And here in the browser, because it's a get, we can see the information that we're getting back. It's an array of objects, and that object has an ID, title, description, URL, start date, end date. So that's one way of doing it. Another way that I really enjoy testing out my APIs here in IntelliJ is by using IntelliJ's HTTP client. Again, they aren't paying me to say this. I just happen to love this feature. Anything I can do to kind of stay within the IDE, it helps me out a lot. So if you hit this drop down next to this get mapping, you'll see it says, hey, generate a request for me in the HTTP client. And what it does is it generates this localhost 8080, and it even figured out that the path that we need is /streams. So I'm going to delete that because I have a bunch of them kind of set up in here for us ready to go. And again, this is just a GET request to 8080 /streams. And if we click play, we will see that our generated request is done, and we get the same information. But unlike the browser, we can test all of our operations, like being able to create and update and delete. So this is a great resource, which I'm going to utilize as we go throughout this. Okay, so we have to go ahead and just create some more methods in our live stream controller. So now the next thing we need to do is we need the ability to get just a single live stream. So let's say we want a method to return a live stream, and we may call this find by ID, and this may take in a string ID, and let's return null for a second. Now we need to annotate this with a get mapping again, but now it's going to take a little bit more information. Now it's going to take an ID, and this is going to be a placeholder for an ID. So just like this one, this is going to respond on a GET request, but it's going to respond on a GET request with the ID. So it'll have that long like UUID on it, right? So this little curly brace ID is basically a dynamic placeholder. And the way that we pull that placeholder out of there is by using a path variable. So the path variable just says, hey, this argument that I've created, string ID, please go ahead and pull that out of the path for me. So it'll assign whatever this is, give it to an ID, and then we can use that. And we can now pass this over to our repository. We can find by ID, and we can pass in our ID. So now if we go back over to our generated requests, first thing we need to do is we need to run the find all, because again, these UUIDs are generated. So let's go ahead and grab that. Then here in the HTTP client, we can say, all right, go ahead and find me just this single one. So I can go ahead and run that. And that one is not found, probably because we need to rerun this. We didn't actually have that find by ID method in there when the server was running, so I needed to restart that for that to take place. So with that, it's going to generate a new ID. Let's go ahead and grab that. And then we'll just go ahead and paste that here. And there we go. So now we just asked for one single live stream, and that brought that back to us. So you can imagine a scenario where you have a list of all the live streams, and maybe I just had a few properties, and then on a web page, you click on one of those to get some more detail about it. This is that instance where you'd say, hey, give me all the details about that live stream because I'm just going to display one of those on a page. Cool. Just looking, no questions. I'm going to keep going. Feel free, Mal, if you want to bug me about anything or if there's any questions coming up.
So Dan, there are a couple of questions. I'm not sure whether you would like to continue with your session or would you like to answer them now?
Yeah, you can go ahead and if they're relevant to things we've covered, we can go ahead and talk about those.
So one of the questions was regarding the auto injection and the field injection. You mentioned that Josh mentions that it's not a good idea to do so. So that's one question if you want to answer it.
Yep. Yeah. So again, with this approach, right? With this approach right here, we are using constructor injection. This is exactly the same as seeing this. It's just implicit. And what that does is now the controller, the controller's constructor accepts an argument of a repository. So now when we want to go ahead and write a test and we want to write a unit test against just the controller, again, if that repository was talking to a database, we don't want to, those are external dependencies that we don't care about when we're testing just the controller. So what we can do is we can create a mock of that repository and pass that mock in as an argument to our constructor. And now we have a way to just test our controller. If you use something like field injection, you know, you have to find a way to kind of mock that repository out and pass it in, and then you're getting into all kinds of reflection fun, which is not fun. Anytime you have to use reflection, unless you're some type of framework developer, you're not going down a good path. So,
makes sense.
I'm sorry, what was the other question?
The other questions are more about what do you think about this topic or the other topic and the comparison. So I think I would ask them to you towards the end of the session, and I'll let you get on with your session.
Okay, cool. So again, we're creating CRUD here. We've created a way for us to get all of the live streams. We've created a way for us to get a single live stream. The next thing we need to do is for a way to create a new live stream. So in this case, this might bring a live stream back. We may call this create. It's going to accept a live stream called stream. And again, let's just return null for a second so we can talk through this. So the first thing that we need to think about is in a create method, we're going to accept a live stream. But the way that we need to accept this is, you know, most of the time when we're using some type of API, we're going to be passing this data in through something like JSON, right? So what I want to do, what I need a way of saying, hey, I want you to bind the request body, whatever is coming in that JSON, to this live stream. I need you to create a new instance of a live stream based on that request body. And the way we do that is, again, by an annotation that's called request body. And so now that underneath the hood, we're using something called Jackson. It's not magic. It's really a really great project though. And it makes all of this so we don't have to write this mapping to make this happen. It's just going to say, hey, if I have a JSON object that looks like this live stream, there you go. I can now create a live stream instance out of that. So that's the first part, is getting that data in. Now what we need to do is we want to, so let's go ahead and do this. We want a post at localhost 8080/streams. So again, this is coming back to the resource. I've seen a lot of this in the past in APIs where you might have something like streams/create, and you don't need that. The stream is the resource, so the path that we're gonna use is just /streams. But again, we're gonna differentiate between this one and this one by the HTTP request method. So instead of using a get mapping now, we're gonna use a post mapping. Okay, so we're using a post mapping there. And one other thing we may want to do is, we talked about some of the building blocks of REST applications. One of those is making sure that we're returning the right response codes. So when you're talking to someone and you're going through, maybe you are at a restaurant and you order something, if you're ordering something, say through a drive-through line, and you say you want that chicken sandwich from Chick-fil-A, there's someone on the other end of that taking that request, right? And they'll be able to tell you right away, sorry, we're out of those today. Or, okay, I got one of those. It's this much money. Go ahead and pull up. When you're working with an API, the response that comes back has some information about that response. One of those is a status code. A status code is like telling you, this is the status of the request that you just sent me. When you're creating a new resource in a REST API, it's good practice to return a 201 status code, which stands for created, so that the caller knows that indeed that thing was created. And so the way that we can do that is we can use this response status, and we can go ahead and give it an HTTP status.created. And that will tell it now when we return that, hey, let's use the 201 status code. So now we can just call our repository. Our repository has a way to create a new stream, and we'll go ahead and create it. If we go back to our HTTP client here, we're going to send a post to localhost 8080/streams. We are setting the content type. We're saying, hey, what we're sending you is application/JSON. And this is one of the things I really love about this tool, is that, okay, we're just generating, back in our Java code, we were generating a random UUID, and we can do that in Java code just fine. But how would I do that in, say, some type of HTTP client? Well, IntelliJ gives us a way to do that using this placeholder syntax here and a UUID. So it's going to create a new UUID for us. And then we're just passing in the title, the description, URL, start date, and end date. So I'm going to go ahead and click run. And again, I ran into the same problem, which is that method is not there. So let's go ahead and run that. And let's run this. And you'll see that the response was 201. So now if I'm a client and I call that, I know that something was created. Okay, so we have our created. Let's see how we're doing on time. All right, okay, we're gonna go here. So the next thing that we need is an update. So I may update this. This is gonna look very similar to live stream. This is gonna look very similar to kind of the method above in the create. But instead of a post mapping, now we're going to have a put mapping. So we may have a URL that looks something like that. And to do that, we're going to use put mapping. And again, we are going to be at /streams/the ID of the live stream that we're trying to update. So again, we'll use that little placeholder syntax. And then we can go ahead and say, go ahead and pull that out using the path variable, the same as we did that above in the get method. Now, from a repository standpoint, we can update, we can pass in our stream, and we can pass in our ID. One more thing I'll add to this is I'll add another response status. Good practice here is to basically say that there is no content coming back. So you may have been expecting something, but in fact, I'm not sending back the updated live stream. I'm just going to send no content back. And then finally, the delete will look something like this. We'll have a public void delete. And we're going to take in a path variable. So this is going to be an ID. And so to do that, we're going to use another annotation called the delete mapping. And again, all of these are just specialized versions of request mapping. This is going to look similar as the one above. We're going to use a placeholder, a dynamic one, so that we can pull out that ID. And there's our ID. And we're also going to say, hey, don't expect anything back. Finally, the repository is going to delete whatever ID we pass in. Let's go ahead and rerun this and go back to our generated. And let's do this. So we're gonna go through and kind of test all of these. So first, let's make sure we can get all of our streams. All right, we can. There's one stream. If I use this ID and I pass it to my find one, can I get just that one? I can. If I wanted to add a new one, can I do that? I can. There's our 201 saying it was created. What I'm going to do is take that one that we just created. I'm going to use that ID and we're going to pass it to a put. And so that put is saying, hey, I want you to go ahead and update that. Again, we're saying the content type is application/JSON. And all I want you to do is change the title from my new live stream to new title. And so if we go ahead and test that out, there's a 204, basically says, okay, there's no content coming back, but everything seems like it should be okay. If we run that, we see our 2 in there, and our second one has our new title. And then finally, we want to take that second one. We grab that ID from there, and we are going to delete that one. So let's go ahead and send a delete request. Again, we should get a 204 saying no content, which we did. If we go ahead and run our find all, we see that we only have one in that array. So that's kind of the CRUD of building out a controller. Now, again, this is kind of the first steps of it. There might be things that you add to this, like paging and sorting. There might be ways to like filter on specific data or search through specific data. But this is kind of where you start if you're building out kind of a CRUD API. One thing I did want to mention is you might see some code that that looks something like this. So we have response entity, and then a live stream. So you may see a signature that looks like this. And if we look at response entity, this is really just an extension of the HTTP entity. And this allows you to kind of control the response that is going back. In our case, so when I'm sending back a particular live stream, I'm just sending back the data of the live stream. But let's say that you needed to manipulate that response that is going back. Maybe you needed to add some headers or some specific, your own specific header or something to do with like authorization or authentication. If you need to manipulate the response that is going back, then you can use this response entity type. And so you'll see that in a lot of APIs that you're working with. So I think that's it for the controller. I know we're coming up against the time, but I just wanted to mention one other thing. So we talked about the ability to validate data that's coming in, right? So if you have a create method here and you want to say, all right, well, I don't want just any data coming in from a live stream. I don't want you to be able to create like an empty title or an empty description. Like I want to validate that. One way that we can do that is by coming into our record. And if you didn't know, you can actually validate, you can use Spring Bean validation. So remember that dependency that we included earlier will work in records as well. It's not just for kind of regular normal classes that you create. You can use validation annotations here in this as well. So what we could say is that we want to control the title, and we want to make sure that this is not going to be empty. So again, if you look in the JavaX validation constraints package, there are a bunch of validations that you can use, like email, or I want to make sure that it has a max or a min. This one that I'm using, which is not empty, past or present, you can follow a particular pattern. It could be a specific size. So there's all these constraints I can put on there. And now if I go ahead and were to pass in something into this controller, I'm just going to go ahead and mark this with @valid. And now when I go ahead and accept that data, it's going to have to pass those constraints. So one of those constraints is don't pass me an empty title. So if you pass me an empty title, it will go ahead and throw an error and won't let you create that new resource. So I think that's, I wanted to get more into validation, but I know we're running up against it. And then just one final thing I wanted to show you. If you look in the repository, so let's find that. If you look in here, if you look in tests, where are we? Source tests. Yep. Controller. Now we went through and we were able to use the HTTP client right there in IntelliJ and test a lot of the things that we're doing. So I typically do this. I just want, for my sanity, I want to know that things are working as expected. But there isn't an HTTP client on your CI/CD system, right? There's a way to run tests and make sure that things work. So on top of that, you also want to write tests against these different methods, these CRUD methods that you're creating. So in the code that you can pull from the repo, here's an example test of how I'm testing out those different methods. So if you want to take a look at that, that will help you out as well. All right. So with that, I just wanted to leave you with some resources. So kind of what is next? We've kind of learned a lot of the basics. What's next? Here's a link for a deeper dive into what is REST. Again, there are 6 principles of REST. We started to cover on some of them today, even though we didn't name them by name. But there are 6 things that you want to kind of think about when you're building REST APIs. Things like they need to be stateless. And there are 6 of these things that you want to conform to. So take a look at that if you want a deeper dive into that. There's a couple of Spring projects that are really great if you're starting to build out APIs. If you want to start documenting APIs. So if you're working in an organization and this team needs to understand what your API does, you want to document that. And one way you can do that is with Swagger or Spring REST docs. Our friend Mala here, we talked about Java 17 today. She has a really great video on learning some of these Java 17 features with IntelliJ IDEA. So I'd advise you taking a look at that. Again, we're moving towards Java 17 in the Spring world this year. So it's good to start to get up on all the features that you're going to be able to take advantage of when you move to, say, Spring Boot 3 and Spring Framework 6. And finally, when you're working in an API, there may be a scenario where you need to call another API. And for that, you'll use something like the REST template in a Spring MVC project or a web client in a WebFlux project. So I think that's all I got. I wanted to cover a little more, but I know we're out of time. So again, thank you. And at this time, I can go ahead and answer any questions you have.
Thank you so much, Dan. That was an amazing presentation, and we have loads of questions. I'm not sure whether we would be able to take all of them because...
yeah, I have a few minutes, so we're good.
Okay. So the first question that I want to start with is, of course, I was expecting this question, comparison about the REST and SOAP. So how they both are different, and did SOAP die? So your opinions are...
So
Appreciate it.
you're probably asking the wrong person because I haven't touched SOAP or RPC in probably 5 to 7 years now. Now, with everything, if you were just going to build a new application, I don't know why you would reach for SOAP, but we don't all live in this great world where we can use new tools all the time. So at the enterprise world, you may definitely be still dealing with SOAP. Um, I, for me, this is just a much easier approach. I don't have a good answer of how they compare to each other, but I have nightmares about SOAP still.
Yes, just a moment. I guess I messed up with the sizing of my windows. Yes, just give me a moment.
No problem.
Oh my God, I can hear you, but I cannot see you. That's funny.
Oh, I'm here, I think.
Yes, and I just want to add to the answer that you just had. So SOAP is doesn't work with a lot of languages. It's not so fast. So developers would have issues with the performance, and um, they would not be able to use JSON a lot. So a lot of constraints. So yes,
Yep.
as Dan said, if you are planning to write your applications today, please prefer REST over SOAP. Um, the other question was about new features for the REST API build in the recent Spring versions, if you want to quickly answer that question.
What new features are they talking about specifically?
So that's kind of an open question. So developers are always excited to find out what's new with this language technology. So if there
Right.
are, um,
I honestly can't think of any off the top of my head. I'm probably missing something, but um, I will have to get back to you on that.
no, no worries. We always have these kind of questions. The other
You know,
one,
again, I think the biggest new thing for me is, again, we're moving towards Java 17. So just being able to take advantage of all the new language features, I'm really looking forward to Spring Boot 3 and hopefully seeing a lot more companies get off of Java 8 and Java 11 and move towards Java 17. So for me, that's going to be the biggest, thing that we kind of start to adopt this year.
yes, makes sense. And a lot of attendees were kind of blown away with the plugins that you were using. And of course, you were using live templates. You had the auto completion with GitHub Copilot, and they were absolutely blown away. We had so many questions about what version is Dan using, and how can I have that gray code auto completion in my IDE.
Well,
So
Well, thanks for the tee up. Again, as I said at the beginning of this conversation, I am a
mm,
huge fan of IntelliJ. I've been using it for, a long, long time now. I'm on the latest version of IntelliJ. Well, maybe not the latest. We are 2021.2.3. So I don't think that's latest. This was October of last year. But that's what I'm on. But again, it is all about if I don't have to leave the IDE to do something, I feel like I'm more productive, right? So the HTTP client was a perfect example of that. I've used tools in the past like Postman or even the browser to kind of view the JSON data. I don't need to do that anymore. So the more that I can just stay in here and get away, the second I open a browser, I don't know about you, but my mind goes to, let's see what's Twitter. Let's see what's going on Twitter now. Or, there's just all these distractions. So if I stay within the code, I feel like I'm more productive. So that is one thing. Live templates are such a great thing, especially for when you're giving demos. There are a lot of, if we were to write out all the code that we went through today, I feel like this would be like a 2.5 hour presentation, and nobody wants to watch me type out all that code. So you can easily create live templates in IntelliJ, and you can break it down into different groups. So for me, this is under Spring Boot, and this is under a specific template folder. So you can keep those. So if I give this presentation again, I can kind of use that. The other thing you can do with that is create a live template for what a CRUD controller looks like, right? Even if you're not using the same like customer employee live stream, you could create a live stream that says, just create me some CRUD methods in a controller so that I know what they look like. So anything that you're going to reuse over and over again, live templates are great for. And finally, GitHub Copilot is just a wizard. So I use it here in IntelliJ and in Visual Studio Code when I'm doing some JavaScript work. And the more and more I use it, the more scared I am of losing my job, because it just like it is it without even giving it context, it will start to try to figure out what I need to do. If you give it context and you start, if you annotate some of your methods with a comment saying like, hey, this should take two numbers and return the sum, it's going to write that method for you. And as you saw, as we got into some of that, even just being able to go, oh, repository, the name of this method is create, you probably want to call the repository create method. And it figured that out. So it's really like an auto completion that is thinking for me, which is amazing. So yeah, take advantage of plugins, look through, the IntelliJ plugin community and find things that work for you. Be more productive that way. Just find one little thing every week, use it, learn it, and then move on and find another one. And the more of these you can get used to and the more keyboard shortcuts you can get used to, the more productive you'll be.
Absolutely. And I would request you to add the name of the plugins that you were using probably in the next presentation that you give, because there's so many questions regarding all of those
Yeah,
amazing
so
things.
that's actually pretty easy. If you go to the GitHub repo, I will go ahead and update that later today in the README with the plugins that we're using. So after this video comes out, the recording of this video, I'll add that in the README as well, but then I'll add those plugins so that you guys have them.
That's great. Then I would take just a couple of questions, and if you think the answers are too long, probably we can skip those.
Okay.
So the first one is, could we discuss which DAO abstraction DAO is better to choose? Repositories, JDBC template, or any other? And what are the pros and cons in each?
Yeah, that is a long question. So it
I
again,
know.
it depends what you're doing. There's especially in the Spring world, there's this great Spring Data umbrella that has all these projects under the Spring Data umbrella, and we can choose different projects based on what we're trying to do, what are the constraints on our project. So that for me really goes on a case-by-case basis, like what you're trying to do. And I don't think I have one blanket answer for that.
I get your point. So, would you like to briefly talk about service versus repository? I think that would
Yeah,
belong us as
yeah.
well.
So for me, a DAO or a repository is something that's encapsulating data logic, right? So in I'm responsible for doing something with data. In our case, it was just an in-memory representation of that data, but the repository is the one that is going to be in charge of finding all the data, finding a single one. A service for me is business logic about our applications. So if I need to, say, send a notification about an order that was just placed, that kind of goes in a service. Service is really my business logic layer. I like to encapsulate data stuff in, say, a repository or a DAO.
Then we have a lot of other questions, but they are going in so many different directions. Someone wants to know the best resources to get started with Spring. Someone wants to know about the REST data. And there's so many questions and of different levels. So it's kind of difficult to ask all the questions because they're going in all the directions. So what I
All
would
right.
do is sorry.
I was just going to say, let's find a way to answer them, though, but maybe not today. So if you want to, you can reach out to me on Twitter. That is not the first time I've gotten the question, how do I get started with Spring? So this is something I definitely want to address now that I kind of get to do this every day. That is a question in a video or an article that I want to go ahead and address. So I will try and get to that one. But I would say the best thing to do is to reach out to me on Twitter or send me an email. I know I'm opening up some floodgates here, but send me an email, danvega@gmail.com, and send me an email with your question. And what I can do is I've kind of been putting these questions together on just like a Notion board, but maybe we'll get like an Ask Me Anything type of GitHub repository for all these questions to go into. But I'd love to answer these questions. So if you have some more context and like, hey, this is the application I'm writing, here is my question, or just a general question on how to get started with Spring, I'd say the best place to find me is on Twitter. And what I'll do is I'll start putting these questions together and find ways to get them answered.
That sounds great. Thank you so much, Dan.
No
amazing session. I managed to learn a lot in the session. And
great.
So if you have any, yes, one thing that I forgot to mention, Dan now works with the Spring as Spring Dev Advocate. So he gets to work with the core team who is working on Spring. So if you also have some feature requests, you can pester Dan about it. No, that's not the right word. You can ping him and request him.
Yeah, you could throw them my way, and hey, maybe that feature already exists and you just didn't know about it. So.
Yes, I was about to say that. Yes, that makes a lot of sense. So thanks everyone for attending, for asking the questions, and for being here, saying hi. And I really hope you enjoyed watching the session and learned as I did. So thank you so much, Dan, and thanks everyone.
Thanks so much for having me. Appreciate it. Thanks everyone for coming by.
Thanks everyone. Bye.